In this video, we'll learn about exponential growth and decay. An exponential function's outputs grow or shrink by a constant multiplier as the output values increase by 1. So what does that mean? Let's look at an example of exponential growth. In the first line of this table, the x value is 1 and the y value is 2. As x increases by 1, the y value goes from 2 to 4. And as x increases by 1 again, the y value goes from 4 to 8. So we see what's happening each time is that we're multiplying the y value by 2 as we increase the x value by 1. To check our pattern, on the last one we go from 8 to 16, which again follows from multiplication by 2. We're supposed to use the following table to record the effect of increasing college tuition by 7% each year, starting from $6,000 in the first year. Well, an increase of 7% corresponds to a multiplier for that percent increase, where we take 1 and then we add the percentage written as a decimal. So that will be 0.07. So our multiplier ends up being 1.07. So to get the second value in the table, or the value for year 2, we're going to multiply 6,000 by 1.07. And this gives us exactly 6,420. So we don't need to do any rounding. Now to get the next row in the table for year 3, we're going to multiply by 1.07 again. And this is going to give us 6,869.4. which now we need to round to the nearest whole number. So we're going to look at our whole number here, move over to the tenths place. That's less than 5. And so we just cut that off and round to 6,869. So we have $6,869 for the third year. Now our instructions told us to round to the nearest dollar in the table, but do not round in your calculator or in your calculations. So what we need to do to get the next row in the table is we're actually going to multiply the unrounded number 6,869.4 by 1.07. That's going to give us 7,350.258, which again, for the table, we're going to round to the nearest whole number. The tenths place is less than 5, and so we'll get 7,350. Now, for the last row in the table, we'll take 7,350.258, and we're going to multiply that by our multiplier of 1.07, which is going to give us 7,864.77606. And now we're going to round to the nearest whole number by looking at the tenths place. This is greater than or equal to 5, and so we'll round up to 7,865. So our last entry is $7,865. In this example, we're supposed to determine whether the following data represents linear or exponential change. And we're supposed to determine whether this is growth or decay. Okay, so what we need to do is look at what's happening as we go from row to row. From row 1 to row 2, we go from 7 to 3, and from row 2 to row 3, we go from 3 to -1. So it looks like what we're doing is subtracting 4 each of these times. Let's check our pattern. In the next one, we go from -1 to -5. That's again subtraction by 4. And -5 to -9, we're again subtracting 4. Since we're adding or subtracting the same amount each time, this is an example of linear change. And since it's subtraction, we're decreasing the amount with each new x value, and so this will be linear decay. Let's do a self-check. Work this one out on your own, and then come back and check your answer. We're supposed to determine whether the following data represents linear or exponential change. And then we're supposed to determine if this change is growth or decay. So let's see what happens as we go from row to row. To go from row 1 to row 2, we move from 1 to 4. And then from row 2 to row 3, we move from 4 to 16. This is definitely not linear growth, because from row 1 to row 2, we added 3, but row 2 to row 3, we added an additional 12. So this must be exponential. Let's take a look. If I multiply by 4 between row 1 and row 2, I go from 1 to 4. And if I multiply by 4 again, I'll go from 4 to 16. And then multiplication by 4 again will get me to 64, and then by 4 again will get me to 256. So this is an example of exponential change. And we're multiplying by a value that's greater than 1, which makes the y values get larger as the x values increase. And so this is going to be an example of growth. So this is exponential growth.